So today we will be talking about angles and standard position. And the reason we're spending a section on just angles is because to understand trig functions completely, you must understand that their domain, or what you plug in, is an angle most of the time. And in the last two sections, we've been saying that angles are measured in degrees. In this unit, you're going to realize that that is not the only way that we can measure angles. But in this section, I want to reiterate something from geometry, that angles could also be viewed as a rotation or a change from one place to another. And that'll be symbolized in just a minute. Before we do that, though, I want to look at the quadrants on a coordinate plane and remind you about which quadrant is what, because that'll also be useful for this unit. Now, this first quadrant, where both x and y are positive, is quadrant 1. And as a memory trick, because the coordinate plane starts with the letter C, you would go from quadrant 1 and make a giant C on your coordinate plane, and so your quadrants would go from 1 to 2 to 3 and then to 4. So I thought that would be useful for some of you. Not only is that a useful trick, also, if you take a look at the y-axis and the x-axis, they have a relationship in terms of an angle as well. The x-axis and the y-axis must be perpendicular, or form right angles, which means if you were thinking about rotating from the x-axis up to this positive y-axis, you would be going 90 degrees. So you'd be going from 0 degrees to 90 degrees, and then if you were going to go from this positive y-axis to this negative x-axis, you'd be going another 90, which would be 180 degrees, and the pattern would continue from 180 to the negative y-axis would be 270 degrees rotated. And then again, if you go back up, it was originally 0, but if you add another 90, you went all the way around, which would be 360 degrees. That also will be useful as we continue on. Another definition in terms of an angle as a rotation. First, we have a couple things to consider. We have an initial side of an angle, which is the starting position of a ray, and it's always on the positive x-axis. And at the same time, I want to point out that an angle always has a vertex, and the endpoint of your vertex is always going to be on the origin. So visually, this would be my vertex, and so I will label it as such. And this would be my initial side, because the initial side is defined as always on the positive x-axis. And so if an angle is a rotation, we need to consider this term called a terminal side, which is the ending point of a position of the ray after it's rotated. So picture that your ray starts here on the x-axis, and then let's say that you rotate a certain number of degrees, and your ray ends up being up here. This would be considered the terminal side. So this is your terminal side. And notice they're both rays, because again, from geometry, an angle is made up of two rays. This was your initial side. And your technical angle, you would draw as such. You were going from the green initial side to the red terminal side. So you'd make a little arrow to represent which direction you are spinning or rotating. And let's call that angle theta, again, because it's a very popular Greek letter for angles. And so this would be an example of an angle in standard position. Now, if you wanted to, that's not the only sketch. You could probably draw infinite sketches. But if you wanted to draw another one in standard position, the vertex would still be at 0, 0. Your initial side would still be on the positive x-axis. But if you wanted to rotate farther, this could be another terminal side, and your angle would be going from the positive x-axis to here. So there's multiple things you can draw, but I wanted to do an acute angle and at least an obtuse angle so you could see that through. Now if we're getting specific with angles, thinking back what I did on the coordinate plane when we were labeling the quadrants, remember that if this is where you're starting all of your angles, this is technically at 0 degrees. If you get all the way up here, it's 90. If you keep going, it's 180, and then 270 degrees. And technically, if you keep going, this would be 360. The reason that's useful is if we're going to sketch what you think the angle looks like, if we're going to sketch 60 degrees, I'm thinking that 60 has to be in the first quadrant because it's between 0 and 90. So the best of the ability, we would draw our vertex, we would draw our initial side, and we would draw where you think that 60 could be. So that you think could be your terminal side, and then you would have to draw in your rotation, and the arrow is important because that is telling me that I am rotating counterclockwise, which symbolizes a positive angle. And so you could just label that 60 degrees, and that would show your rotation. If we were going to go to 225 degrees, feel free, if you would like, to label this as 0 degrees, 90, 180, 270, and again back to 360. If I drew my angles of rotation, here's my vertex, initial side, 225 degrees. We're going to be going through the first quadrant, through the second quadrant, and we're between 180 and 270, so I'm guessing we're landing somewhere in the third, maybe about there. So what I would do is draw my terminal side in my third quadrant where you think that is accurate. So we went from the initial side, and in purple here, again, our rotation was all the way around, drawing an arrow. So this right here would be my 225 degrees. The third example, 270, there's my vertex, here's my initial side. If I am rotating, we are going from 0 degrees, going past 90, going past 180, and we're landing exactly at 270 degrees. So my rotation would end here. So if I wanted to redraw my angle, there is my initial side. Here is my terminal side. So my rotation is from the 0 all the way around. So that rotation there would be 270 degrees, counterclockwise. With that in mind, let's take a look at negative angles. And when we're done with these, I'm going to give you time to try some on your own and check back with me. What's interesting about negative angles is you can think somewhat backwards. This is still 0 degrees, but now we're doing a clockwise rotation, which gives you a negative angle. So instead of going up to 90, down here would become negative 90 degrees. This would be negative 180, and then negative 270. So if my goal is to find negative 45 degrees, I would still have the vertex at 0, 0. I would still draw my initial side, but 45 degrees, negative 45 degrees would be between 0 and negative 90. And I think it would be exactly between. So again, the best of your ability, you draw your terminal side and then represent your angle as a rotation from the positive x-axis to your terminal side, and that would be your negative 45 degrees. So again, it is important to write the arrow to show what direction you're moving. If we were to go to negative 315 degrees, again, feel free, 0, negative 90, negative 180, negative 270, and again, technically I didn't do this last time, but that would be negative 360 degrees. So if you're doing negative 315 degrees, you would still put your vertex here, your terminal side, and then you'd say, okay, if I'm rotating negative, I would go past the 90, past the 180, past the 270, and probably back into the first quadrant, oddly enough, because it's about 315 degrees, which is between negative 270 and negative 360. And so I would draw in a different color. Let me pick red. Again, here is my, let it change. Here is my initial side. My terminal side would probably be something along there where I stopped my rotation. And in purple again, I want to reiterate that this is your angle showing the rotation counterclockwise. Last but not least, negative 180 degrees. If you're going to draw your vertex, initial side, label 0 degrees, negative 90, negative 180, negative 270, and then negative 360, I would say that you are rotating negative 90 degrees and then landing directly on negative 180 degrees. So your angle this time is going to start here and end here. So this is your angle of rotation, counterclockwise. So now it's time for you to try. A little bit of positive, a little bit of negative. So what I'd like you to do is pause the video, please. As you are doing so, I'm going to be doing the problems as well. And when you unpause, you can check your answers with me. Please pause the video now. All right, guys, so to check back in with you, technically, remember your angle is your rotation, so please make sure in the first one that you have this blue right here. This is your with the correct direction. Should be counterclockwise, which represents a positive angle. In number 2, you would have to go all the way around to the 4th quadrant, about almost back to 360. The third one, we are going negative or clockwise this time, a little bit past negative 180 degrees to a negative 190. And then the last one, you were going from 0 down to negative 90. And so all of them, just make sure your arrows are going in the right direction. Make sure you are drawing both your initial side and your terminal side for each one. If you got these all right, great job. We are trying to have you understand the rotations in degrees, again, before we do any other type of way to measure angles. So again, guys, thank you so much. If you have any questions, feel free to ask any of us in class tomorrow. All right. Thank you.